Assalamualaikum and good evening. So my name is Muhammad Haikal bin Muhammad Razi. My metric number is AD170147. So I on behalf of Team 7E. So now I want to talk about the theory strange God experiment. So basically, this experiment permit a simple and reliable determination of stress and strain distribution at component under load. So we use this training system which is FL100 that show us the fundamental of strain gauge technology and to investigate the simple mechanical load for three type, which is tension, bending and also torsion. So for the theory, we must know the all the three formula for us to conduct the experiment. So for the bending, this is the epsilon equal to 1 over k times VA over VE for formula for bending, where stress is equal to m dot y over I. So so we know the modulus elasticity have been fixed, which is 210 times to 10 over 3, which is 200 210,000. So next is for the formula torsion. Epsilon is equal same as the formula bending, as we can see here. Epsilon equal to 1 over k times VA over V. But now we must find the T, which is theta equal to 2E dot G. And then the torsional moment also we need to calculate, which is T equal to omega, which exactly omega, where T not same as this, we must find the new T, which is by this formula, which is T equal to TR over J. So next for formula of tension, no sorry, formula for tensile, the formula is different from the bending and torsion formula, which is epsilon is equal to 1 over 2 times 1 plus nu times 4 over k times VA over VE, where the stress is E plus epsilon. That's all.
Assalamualaikum, my name is Muhammad Anas bin Azlan. I will be presenting the experimental result. The data that we collected from the experiment and calculation is recorded in this table contain of load in Newton, bridge and stress in Newton per millimeter square. Here are the first table for tensile experiment of steel. With its graphical form of load and stress shown, the result is directly proportional with its positive slope. Next is the table and graph recorded for bending experiment. The graph shows the result is directly proportional with negative slope. And lastly, the torsion experiment. The graph is directly proportional and have positive slope. That is all for result of the experiment. Thank you.
Hello, my name is Muhammad Ikmal Bismail. My metric number is AD170092. For this experiment, I'm going to explain to you the observation of the experiment. So for the observation, there's two error, which is the first is experimental error and second is systematic error. For the experimental error, involve dimension. This experiment was human error affecting the dimension. This is because when adding the load, there might be a slight effect of an adding the extra load of human hand pushing down the beam, and it might give an effect of the deflection of the beam, especially on the bending experiment compared to the tensile and torsion experiment. But this error can be solved by performing the experiment several times. So for the second is the systematic error. The systematic error is because of the faulty calibration of measuring instrument that are poorly maintained instrument or faulty reading of the instrument by the observer. So that's all for me. Thank you.
Hi, my name is Muhammad Hazim bin Noor Yusuf Azam, and my matrix number is AD170071. So today I will present regarding our calculation. So for first calculation, which is the theoretical calculation for tensile experiment, it was given that the area is 20 mm square. So for force equals to 10 Newton, and we just substitute into this formula for the stress, we can find that the value is 0.5 Newton mm square, Newton per mm square. So this calculation will be repeated for force 20 Newton, 30 Newton, 40 Newton, and 50 Newton. So the calculation is the same. So move on to second calculation, which is the theoretical calculation for bending experiment. So this is what has given the length and also the second moment of area, yeah, the moment of area. And for force 0.49, you can get the MB negative 188.84 Newton mm. And when you substitute into this formula, and we can get the answer of the value is negative 2.543. And this also will be repeated for force F equals to 0.98, 1.47, 1.96, and 2.5 Newton. Then we move on to the last calculation, which is the theoretical calculation for torsion experiment. We want to find the tau. This is the formula, and it was given that the length is 500 mm and the second moment of inertia is 196.33 mm cube. And for force equals to 2 Newton, you can get the MB equals to 1000 Newton meter. Then we substitute the value that we get and the given value towards this value, we can get 5.09 Newton mm square. And in this calculation also will be repeated for force equals to 4, 6, 8, and 10 Newton. And yeah, this is all from me. So thank you.
Assalamualaikum. My name is Muhammad Azam Iskandar bin Abu Bakar. My matrix number is CD 170111. Today, I would like to present about conclusion for our group lab report. For this experiment that have been conducted is related to the measurement of using strain gauge to a material property and determine the effect of electronic circuits on the accuracy of measurement. The stiffer the material, the higher its modulus elasticity. The largest number of active strain gauge, the greater the accuracy that mass estimate. Lastly, for our conclusion, we'll conduct a successful experiment and we get all data for our experiment. That's all. Thank you.